Welcome to Simply Sports Science, your go-to channel for making PE, sport and exercise science simple, clear and genuinely useful. Whether you're an IB, GCSE or IGCSE student or a teacher looking for high quality resources to help your teaching, this is the place to level up your learning. Don't forget to like, share and subscribe so you never miss a new episode. When we talk about endurance performance, whether it's a long run, a tough cycling stage, or a repeated effort in a team sport, two key factors come up again and again: VO2Max and running economy. Together, these two elements help explain why some athletes can keep going at a fast pace with ease, while others struggle even when trying their hardest. So let's start with VO2Max. VO2 max is simply the maximum amount of oxygen your body can take in, transport and use during intense exercise. It's often seen as the gold standard of aerobic fitness. The more oxygen your muscles can use, the more energy they can produce, and the longer you can sustain hard effort. But VO2 max alone does not tell the whole story. Two runners can have the same VO2 max, yet one may run faster with the same level of effort. Why? Because of running economy, sometimes called movement efficiency. Running economy describes how much oxygen you need at a given pace. If you use less oxygen at the same speed, you're more economical, and that means you can run faster for longer. The best endurance athletes in the world don't just have a high VO2 max, they also move with incredible efficiency, wasting very little energy with each step or stride. So endurance performance is really a combination of how much oxygen you can use and how well you can use it. Now let's look at the key factors that influence VO2 max, starting with age. VO2 max naturally increases through childhood and teenage years as the heart, lungs and muscles grow stronger. It typically reaches its peak in the late teens or early 20s. After that, it slowly declines with age, mainly because the heart becomes slightly less efficient and muscle mass begins to decrease. But the good news here is that regular training can slow this decline dramatically. Many older athletes maintain impressive VO2 max values because they stay active and keep challenging their cardiovascular system. Next, we need to consider gender. On average, males tend to have higher VO2 max values than females. This is mostly due to biological differences such as larger heart size, higher hemoglobin levels, and greater muscle mass. These factors allow males to transport oxygen more effectively. However, when we compare athletes of equal training backgrounds, the gap becomes much smaller. Many highly trained female athletes have VO2 max scores equal to or even greater than untrained males. Training remains the biggest influence here. Another important factor is body composition. VO2 max is usually measured relative to body weight because heavier bodies require more energy to move. Higher levels of body fat can reduce relative VO2 max simply because excess mass increases the demand on the cardiovascular system. On the other hand, lean muscle mass helps improve oxygen use because muscle is the tissue that actually consumes oxygen during movement. This is why endurance athletes often have a slight lean build. They carry just enough mass to generate power whilst avoiding unnecessary load. Now let's look at lifestyle factors because these play a huge role in determining aerobic capacity. Regular physical activity improves heart strength, increases lung capacity, boosts capillary growth in muscles, and encourages more mitochondria, the structure that produces aerobic energy. On the flip side, a lifestyle with little physical activity will do the opposite. Poor sleep, stress, and alcohol consumption can all reduce overall fitness by affecting energy systems, recovery, and cardiovascular health. Even something as simple as spending too long sitting can gradually reduce aerobic capacity over time. Finally, we must consider fitness and health status. Aerobic training, especially steady-state running, cycling, swimming, or interval training, can significantly increase our VO2 max. Athletes who consistently train their aerobic systems develop stronger hearts, develop more efficient breathing patterns, and can generate better blood flow to active muscles. Health conditions such as asthma, heart disease, or respiratory problems can all limit VO2 max by reducing the body's ability to move oxygen efficiently during exercise. This can make endurance performance more challenging even if the person is motivated and well trained. But remember, VO2 max is only one part of the endurance story. The real magic happens when your VO2 max combines with efficient movement, especially running economy. Running economy is influenced by technique, strength, flexibility, and even footwear. Small improvements in running form, like reducing unnecessary up and down movement, improving posture, or landing softly, can dramatically reduce the amount of oxygen needed at any given pace. Stronger core muscles help maintain good alignment. Strength training improves leg stiffness and force production. Even practicing running at a range of different speeds will help an athlete develop smoother, more economical movement patterns. And this is why endurance athletes train so carefully. They don't just aim to boost their VO2 max, they spend huge amounts of time improving their technique, building strength, and learning how to move with rhythm and consistency. Improving running economy means that even if VO2 max stays the same, performance can still rise sharply. A great example is elite marathon runners. Many of them have good, though not always world record-breaking, VO2 max scores. What sets them apart is how incredibly efficient they are. Their running economy is so smooth and precise that they can run at high speeds using less oxygen than other athletes doing the same pace. This saves energy, it delays fatigue, and it allows them to maintain world-class speeds for much longer distances. So when we think about endurance performance, VO2 max is important, but it isn't the full picture. The ability to take in and use oxygen sets a foundation, but how efficiently you move determines how far and how fast you can go on that foundation. Two athletes might breathe in the same amount of oxygen, but the one who moves more smoothly, more economically, and with better technique will always go further. Understanding VO2 max and running economy together helps us see endurance performance not just as a test of fitness, but as a blend of physiology, skill, and smart training. The strongest endurance athletes aren't just fit, they're fit and efficient. Thanks for watching Simply Sports Science. If you found this helpful, make sure you like the video, subscribe to the channel and hit the bell so you don't miss any of our IB Sports Science content. We've got revision guides, exam tips and clear explanations to help you be successful. And don't forget to visit us at www.simplysportscience.co.uk. Join us again next time where we'll keep making sports science simple.